Okay guys, I hope you had a good spring break. This is AMI day 5 that you should have done Monday right when we got back from spring break. So the thing that maybe made this one complicated is thinking backwards and realizing this is an AB question and not a BC question. So everything is just in terms of this equation right here. We don't have a x equation and a y equation, it's just that equation. So for part A, we want to decide when that particle is moving to the left. So when it's moving to the left, that would mean the velocity is negative. When it's moving to the right, that would mean that the velocity is positive. So what we really need to do is find when the velocity is equal to 0. So we are going to set cosine of pi over 6t equal to 0, and then we need to solve that. So just thinking through like unit circle, cosine is going to be equal to 0 at pi over 2 and at 3 pi over 2. And we need this pi over 6 because that's inside of that velocity equation. But we don't want pi over 6t, we just want t. So we're going to have to multiply everything by 6 over pi to try to figure out what those t's are actually going to be. So the pi's are going to cancel, and then 6 divided by 2 would give us 3. For this next one, 6 times 3 would be 18, divided by 2 is 9. So those are going to be our two values when the velocity is equal to 0. What we need to figure out now is what the velocity is doing in between those times. So we already know here that it's equal to 0. We need to see what it's doing outside of that. So let's plug in something in this interval like 1. So if we plug in 1, that means we just want cosine of pi over 6. Cosine of pi over 6 is in the first quadrant. That means it's positive, so it's moving to the right. If we plug in something in between 3 and 9, maybe let's say 5. 5 pi over 6 is in the second quadrant. Cosine's negative in the second quadrant, so that means we are moving to the left. And if we plug in something bigger than 9, let's say 11. 11 pi over 6 is in quadrant 4. That means it's positive, so it's moving to the right. So when is it moving to the left? It's moving to the left for 3 is less than t is less than 9, because v of t is less than 0 on that interval. Now for part B, we want to write but not evaluate an integral expression that gives the total distance traveled. So again, this is not a BC question, this was an AB question, so this isn't like an arc length thing. This is knowing that when we integrate your velocity, that is going to give us the position. And it gives us the position because when we integrate velocity, it includes positive area and negative area. But if we wanted just like the total distance traveled, that means we would only need the area to be positive. So the thing in math that gives everything positive is absolute value. So that's going to just take that, and anything that was negative, it's going to shift it to positive. So when we integrate, it'll give us the total distance that was traveled. So we want to integrate from 0 to 6, and it says write but do not evaluate. So that is all we got to do. Part C, we're going to find the acceleration. So first thing, find the derivative. So the derivative of cosine is negative sine. Keep the inside. Then we multiply by the derivative of the inside, which is pi over 6. So then it asks, is the speed of the particle increasing, decreasing, or neither at time t equals 4? So this is kind of like a physics thing. If velocity is positive and acceleration is positive, or velocity is negative and acceleration is negative, that means it's going to be speeding up. Vice versa, if velocity is negative and acceleration is positive, or velocity is positive and acceleration is negative, that means it's slowing down. So we already know v of 4 is less than 0 from what we did in part A. So we now need to find a of 4. So we're going to plug in 4. So that's going to give us negative pi over 6 sine 4 over 6 simplifies to 2 over 3. So what I'm really concerned with is if this thing comes out to be positive or negative. I don't actually need to know the number. 2 pi over 3 is in the second quadrant. In the second quadrant, sine is positive. So since sine is positive and pi over 6 is negative, that means this is less than 0. So that means the particle is speeding up because v of 4 is less than 0 and a of 4 is less than 0. Okay, last thing, part D. We want to find the position of the particle at t equals 4. So we know the position of the particle at t equals 0. So this is similar to something that we did with vectors. We know the position at a smaller point. We need to know the position at a bigger point. So that means we're going to take the initial condition we know, which is x is equal to negative 2. Since we know the smaller one, t equals 0, and we need to find the bigger one, t equals 4, that means we need to add the integral from 0 to 4 of cosine of pi over 6t dt. It does want us to actually find it, so we need to evaluate that integral. So we're going to have negative 2. The good news is we already did the derivative here. So the derivative, we had a negative pi over 6 out front. So our integral, we're going to have to put the opposite, which is 6 over pi sine of pi over 6. And that is going to be evaluated from 0 to 4. So with integrals, we do top and then bottom. So we're still going to have that negative 2 out front. So the first one we're going to plug in is 4. So 6 over pi sine of, when we plug in 4, that's going to be 4 pi over 6, which is the same thing as 2 pi over 3. Then minus 6 over pi sine of 0. I left off the t over here, guys. I'm sorry. Now sine of 0 conveniently is 0, so we don't have to include that. But we do need to know unit circle stuff here. So sine of 2 pi over 3. So if you don't remember them exactly, if you can think it through just in the first quadrant, that'll help you with the other quadrants. So pi over 3 is right here, so the y value is bigger than the x value. So that means sine of 2 pi over 3 is in this quadrant, so it still is going to be square root of 3 over 2. And we could, I guess, simplify that a little bit, but the only thing I would want to do is simplify that down to 3. So you're going to have negative 2 plus 3 square root of 3 over pi. So that is going to be the position of the particle at t equals 4. So that was AMI Day 5. Make sure you guys look at the classwork tab on Google Classroom to make sure you're doing the right assignments for this week after spring break. Thanks, guys.